Problem number 7, if we subtract 3 from both sides, we get 2 times the sine of theta equals -1, and we get then the sine of theta equals -1/2. Now, we're solving the equations that we see here, 7 through 10 in the right-hand column. We're solving these equations on the interval from 0 to 2 pi, including 0, but not including 2 pi. This is different. I just want to point that out, and I explained this as well in the first version 1 videos, that inverse trig expressions have one value. Always. Inverse trig expression is only one value. But when we solve equations, even though we're still dealing with trig, when we solve equations, we're trying to find all the angles that are in between 0 and 2 pi that make the equation true. So many times there will be 2. And so really try to make sure you understand the difference between solving an equation and expressing the value of an expression. Okay, this is different. That's why you only get one angle on the left side, 2 or more on the right, possibly. Anyway, so the sine of any angle, if the sine of the angle is -1/2, the angle has to be 7 pi over 6. That's the third quadrant. And then also the fourth quadrant, 11 pi over 6. That's it. Now, the cosine is equal to -1/2 when the angle, I initially said, okay, if you want to visualize this maybe a little bit easier, just treat this like cosine of u equals -1/2, where the u value then, the angle would have to be, where is the cosine equal to -1/2? Well, the cosine is negative in the second quadrant as well as the third quadrant, so second and third. And since the cosine is the x, when you go over 1/2 to the left, you go up to that angle right there. That's 2 pi over 3. And then over to the left, and then down to that angle. That's 4 pi over 3. And then if we, remember, 2 theta, that means we have to go 2 times around. So if we count by pi over 3's, we go 1, 2, 3, 4, 5, 6 pi over 3. So 6 pi over 3 gets you back around the circle, because 6 pi over 3 is 2 pi. And then 7, 8 pi over 3. So 8 pi over 3 is going to put us back in the second quadrant. 9, 10 pi over 3 is going to put us back in the third quadrant. So those are our 4 angles that u is equal to, but then that means that when we replace u with 2 theta, put 2 theta back in, we get 2 theta equals all these angles. I wouldn't recommend writing this out again, but I want to just show so there's no doubt what we're doing here. Now, we're not solving for 2 theta. What we're doing is we're solving for theta. So we have to multiply both sides by 1/2. Find that visually more pleasing than dividing by 2. Like if you divide 2 pi by 2, sorry, 2 pi over 3 by 2, then it looks a little bit tricky, but multiplying by 1/2, you can see you're going to cancel. Every time you have an even number in the numerator, you're just going to cancel that 2 right there. So 1/2 times 2 pi over 3 becomes pi over 3. 1/2 times 4 pi over 3 becomes 2 pi over 3, and so on. 8 pi over 3 becomes 4 pi over 3, multiplying it by 1/2. And multiplying 1/2 by 10 pi over 3, we get 5 pi over 3. If we kept going, we would extend beyond our 2 pi limitation. So those are the angles between 0 and 2 pi in which that make this equation true. All right, I'll do one more video for the last two.